No problem. I had extra money burning a hole in my pocket. All right, so here we are. We are going to jump back in. We did not finish this problem the other day. I've left the annotations, but I want to make sure that we're still on the same page. When we run through one of these problems, which can somebody remind me, we are completing the square. Why? What's the end goal here? To write it in my standard form or my vertex form, my graphing form, whatever I wind up calling it. Vertex form is natural for me. Standard form is also good, but I'm going to identify HK as my vertex, and then we can just make graphing these things super easy. Now, we'll do a few problems today because I'm well aware that when we talk through this one and we graph it, you'll be like, well, that was like 20 minutes to graph something that didn't really need 20 minutes. By the end of today, or even after a few examples, my hope is that that 20-minute process becomes like a 5-minute process maximum, which will still be faster for graphing. Okay, so anytime we're doing these, I'm going to group my x terms together. So we'll go ahead and just knock that out. Parentheses 2x squared plus 4x. And you guys already have all this. I just want to make sure that we get caught back up. Why do I factor the 2 out of that group? I need the leading coefficient inside to be a what? A 1. But right now it's a 2. So I'm just going to factor the 2 out. So doing so, we get 2 times x squared plus 2x minus 5. Okay. Now, I will show you guys how to write way less as we're doing these, and it just takes a little bit of practice. We now look at this thing inside the parentheses. That is not a trinomial yet, but we're going to make it perfect. If I treat this as if it's the only thing that exists, we have a A, which is a 1, a connected. We have a B, which is 2, and no C in there, right? So we have to add our C in, but we can't just add whatever we want to a problem. The only thing that I can add without changing stuff is a clever choice of which number. 0. I can multiply by a clever choice of 1, but I can add any choice of 0 that I want. So when we look at these, you take the B term, quote unquote, inside my parentheses. We divide it by 2, and then we square it. So if I'm thinking 2 divided by 2 is 1, and I square it, I get 1. So inside of my parentheses, I'm going to add my 0. So here we go, x squared plus 2x. And when I took that term, divided it by 2, and squared it, what was it again? I take 2, or b in this case, divide it by 2, I get 1, and I square it. What's that number? 1. Now, what am I really allowed to add without changing something? A 0. So when I add a 1, I'm also going to subtract a 1. Now, I think a part that I get hung up on because it seems like magic when we do it, I've added, and I'm claiming to you guys in one of 2 ways to be true, that I've added 1 and subtracted 1. Everybody on board with that still? Now, last class I made a comment that, well, really though, I added 2 and subtracted 2. Do you recall how I came to that statement? There's a, good job, Rafa. There's a 2 out front that has to distribute, right? So if I were to distribute that through, it would have been plus 2 and minus 2 there. Now, I don't want the negative inside of here. And these steps might look a little bit different. I want this 1x squared, I want the 2x, and I want the plus 1. So this is going to look different than your notes. You don't have to change yours. Keep these and remove this. Now, remember, it's stuck to multiplying by that 2. So to remove it, I have to distribute that 2 to whatever I want to remove. Only the negative 1 is all I want to take out of this. So here we go. And let's pick up here. We have a 2 still. We have x squared plus 2x. Is there anything else inside the parentheses? Plus 1, love it. And then I don't care about the order. It's entirely up to you. Does it feel more natural if I say minus 5 because that's what was there, and then that minus 2? Or does it matter if the negative 2 comes first or second? In my mind, for whatever reason, I want to do this because it looks like I'm distributing in and it's in between anyway. There's no real right or wrong as long as you're subtracting the 2 that you've taken out. Okay, I'm 2 steps away. I'm going to clean up this here, plus 2x plus 1, and then outside I get a minus 7. I can already tell you the k value. my vertex guaranteed the y value is 7. I can see it right now. Awesome. Beyond that, we have inside of our parentheses a trinomial. But it's not just any old trinomial, it is perfect in square. Meaning there is a really easy way to factor this. When we went through our factoring checklist, I think I mentioned the perfect square trinomial stuff. If you don't recall it, that is okay, because we're going to see it right now. If you wanted to factor this thing, just what's inside parentheses, run me through the list, and I'm just going to get my calculator somewhere. Number 1, what would you do to factor this? What's the first thing you always check? Number 1, I don't know who that is. Greatest common factor. Is there one? So is there a meaningful greatest common factor? Because you're right. You're gonna always be right if you say 1 is a common factor. Anything other than 1 is all I'm asking for. Okay, so we've checked greatest common factor. There is not. Number 2, what's next then? Love it. You skipped a bunch of steps, but that's definitely where your next step would be. It's not a binomial, so we don't even have to check difference of squares. It is a trinomial whose leading coefficient inside my parentheses is what? Indeed, it's a 1. 1x squared right here. Why is that like the coolest thing ever? Shortcut. What? Okay. 1 times 1 is 1. Can you guys give me factors of 1 that add up to 2? It's 1 and 1, right? Now, that means that one factor is x plus 1, and the other factor is x plus 1. Is there a more convenient way to write that? It's just squared, right? So, this is a perfect square trinomial. If you want me to show the factoring out to the side, I can. 2 times x plus 1 squared is how that winds up factoring. Minus 7. We are now in our vertex form. Okay. We'll do another one because it's super weird to come in mid-problem. Can you guys, checking your notes, because I asked us, I think, to find this and then sketch it, can you tell me where the vertex is? And I'm going to zoom out here for a second. Here's my vertex form, if we recall. A times x minus h squared plus k. This is it. X minus h is going to be part of that. What am I subtracting? X minus what to obtain x plus 1 inside of my parentheses here? This is always a weird question. Maybe. Number 4. What am I subtracting from x inside my parentheses that produces an x plus 1 instead? What am I? So what's h is the shorthand version of that question? Not quite 1. Why? You are correct, just so you know. It is negative 1. As I'm looking at it, notice in your standard form it's x minus h, right? X minus what turns it into plus 1? Negative 1. And there's your justification. I know the vertex is at negative 1, comma, what's the value of k? So it's plus k, right? So it's just a regular whatever k shows up as. Now, the reason we would care about this, again, 1, this will tell us guaranteed either our minimum or our maximum. This parabola, what's its leading coefficient? 2, which means how's it open? Right, like this, with a little dance move on it. Okay, as we're going through, I know it opens up. I know the minimum of this function. The smallest value this thing ever gets to is negative 7, because I can see that y value at the vertex. As we graph it, I'm going to make a little table. We really need 5 points when we're graphing. Like, that's what we need. But I'm going to make the claim we only need to write 3 of them. So let's make a small table real quick. And just so you guys are aware, if you are mental math-tacular, I have no issue whatsoever if you don't use 3-column tables, with the understanding that on a quiz or a test, if you don't, I can't find a mistake and give you partial credit. Okay. Going through here, what's the first value we should plug in for x? Negative what? Negative 1, the one that I'm already expecting. Now, if you want to see it, we can. I'm going to do a little bit of mental math. This becomes 2 times 0 squared minus 7, and it's negative 7. That's what we should expect. I get the point negative 1, negative 7. Now, remember when you're choosing these x values, you literally have infinitely many of them to choose from, but we want the easiest possible things to square. 0 squared is easy. What's the next easiest thing? So 1, cool. What value of x would you pick to make inside of this square x plus 1 squared? I want this to be a 1. Let's pick a 0. And now we'll just mental math it. What's 1 squared? Indeed, times 2 is 2 minus 7. Negative 5. 0 squared is easy. 1 squared is easy. What's the next easiest thing to square after 1? 2. I was expecting somebody to say negative 1, but 2 is the one that I would go with. What value of x would you pick to make this equal to 2? 1. So this would become 2 times, we have a 2 inside now, squared minus 7. What's 2 squared? So I have 2 times 4 is 8 minus 7 is 1. Okay, we have 3 points. Is that easier than having to do ugly points? Like if I just given you this vertex form, can you see the value in it? I'm not trying to trick you, like legitimately. Maybe you don't. Is that easier to graph? I think so, but that's kind of subjective. So let's check out our graph real quick and just see if it works nicely. So I know that this is only half of it, right? So if I went to negative 1 and I went 2 to the right, I'm probably going to go 2 to the left on my graph as well. So I need to go at least to negative 3, and I'm looking at my values. Here we are. Now, as I'm going, I can't see the grid very clear. I can see it really clearly on this board, but on this one, I'm just going to say negative 1, negative 2, negative 3. Positive 1, and then I'm just going to do the following, negative 5, and I'll just eyeball it out, because all we're doing is sketching. I should probably be more formal. X. Do you guys call this y or f of x? Y. Cool. I think I can plot these 3 points pretty easily. Negative 1, negative 7 lives about there. I think. 0, negative 5 is about there, and 1, positive 1 would be about there. These are the only points that I have. That's the best I've ever gone through 3 points on the board. If I stop right here, I'm breaking my own heart because we did all that work and we're not quite right. I've only graphed the 3 points that we included. What else do I do? Say it again. I think you're right, but I could just, what was the word you said? Yeah, just reflect it, right? What did you actually say? Other side, okay. So you do not have to include this. I'm going to use this lovely red line to say reflect over that, and we'll just eyeball it out. This point is 1 away, 1 away. This point is 1, 2 away, so 1, 2 away. Same y value. That certainly looks like a parabola-ish to me, and we have it. Now, the graphing part of it just on its own is nothing too crazy. The most challenging part, by a long shot, is getting it into this form. So, if I ask, there's some natural follow-up questions that we can ask, though I won't write them down yet. Can you guys tell me the domain of that function? I bet you can. All reals. The range, typically people think that domain and range stuff is challenging. Like it is, it's conceptually kind of out there. The range is just the y values we use, right? This, what's the lowest y value ever used? And everything above it gets used, right? So the range is -7 to infinity. And I can already see it. It's hard if you don't have the graph, but with the graph, it's a piece of cake. Other things I might ask, can you tell me where the roots are? The zeros, the solutions? Not exactly, right? However, I see that my function goes from being negative to positive right here. The y values go from negative to positive. What must I have crossed over somewhere between 0 and 1 then? Say it again. The x-axis, or a 0, a root. I can see that there's 2 roots on this. I don't know exactly where they are, but we don't trust our graphs to tell us exactly where they are anyway. All right, so I need to check to see how much room we have. We're going to do another one. And I'm trying to decide where I want to work it. Should we do one more together before I cut you guys to try to do it on your own? Surely. All right, so I will rearrange everything. I just want to make sure I can see it nicely. I think this will fit. Do you guys ever look at the notes when I post them, like these ones? Ooh. Okay, I will keep doing that then. So we did A, B, and this is going to look odd because C is going to be underneath. I don't know what that graph is for. I'm just going to delete it. Get out of here. Backspace. Okay, guess not. All right. How fractiony do you want to get? Okay. Breaking my heart. So this is example C, and it's going to be all goofy. Here we go. What's your favorite number, Angel? 5. Cool. So let's deal with the function f of x is equal to 5x squared minus 20x plus 1. Now, you have all the annotations from before. I would rather, on this one, like to show you exactly how I write it down, and I'll talk it out, but it is so much less writing than the one that we did just now. Okay, first thing that I noticed is there's something I don't like about this one. Can you tell me that number 5? Is that you again? Okay, number 6. What don't I like about this particular quadratic? I don't like the fact that the leading coefficient is not 1. Man, well, what should I factor out of the x terms, or anything with an x, to make sure that my leading coefficient is 1? 5. I'm going to factor out the 5 because I want this to be a 1. Now, this is going to look wildly different. Okay, I'm going to do several things. I'm going to factor out a 5 only out of these. So I'm going to be left with x squared minus 4x. And then check this out. It's really annoying, but it's intentional. Plus 1. I left this extremely unappealing blank space on my page, but I've done so for a very intentional reason. I need to add something in here, right? Now, really I'm adding a 0, which means I just have to add and subtract the same thing. And all I really need to know is what do we add and subtract into this number 7. Isn't it, I think it was 3?
Yeah.
So it was 1 last time. How did we get 1 last time though? You take the b term inside my parentheses and you divide it by something. So let me show me your last problem. Okay, so check it out. When we get to here, we took this guy, this one, and we divided it by 2, right? We're going to divide by 2. So let's take this term and divide it by 2. Meaning, we're going to take this negative 4 and divide it by 2. We get what? So I get negative 2, and then I'm going to square it. Careful. Negative 2 times a negative 2 is what we mean when we square. I like the positive version of it. Now, while we do this, I'm always going to write the positive one first. Plus 4 minus 4. I haven't changed anything. I've added a 0 in here. Now, alternatively, one could say I've actually added 20 and subtracted 20. So it's the same idea, because the 5 is going to distribute through. Which of those 4s don't I want inside the parentheses anymore? I don't want the negative. Okay, so I'm going to take the negative 4 out. But in order to get it out, I have to carry out which operation? It's already written there, number 8. To get that negative 4 outside of my parentheses, I can't just move it. I have to do something else first. Because it's I'm going to distribute it. So I'm going to multiply it by what? Love it. I'm going to multiply it by 5. And I'm going to actually include one more step than I normally would. But we'll just jump in right here. So I now get 5. Then inside my parentheses, x squared minus 4x plus 4. And then I distributed the 5 to the negative. So I'll take out a negative 20 and plus 1. Okay. I'm going to give us an alternative way to factor these. You can always group them. But there is another shortcut that just looks a little bit different. Instead of having to go through the grouping, I'm going to demonstrate the shortcut again. This thing, we've gone through everything we needed to make it perfect. Like this is a perfect square, which means it's going to factor super nicely. Can you tell me the square root of this? It's x. And then can you guys tell me the square root of the 4? And then what's the sign? And this is goofy. It's not going to fit nicely. That's an x. That's a 2. And then what's the sign on this middle term? Negative? So check it out. There's our shortcut with perfect squares. We still have the 5, but our factoring comes out to be an x, a 2, and what was the sign between them? Negative squared, and I think it's minus 19. We're done. Can you tell me the vertex? You're so close. Positive 2. Because remember it shows up in that x minus h, and h in this case would have been 2. Okay. Do we need to graph it? I mean, can you, without actually doing it, from this form right here, what's the first x you're going to plug in? 2. What's the next one? Why? Good. If I plug in an x equals 3 into this expression, it makes it 5 times 1 squared. Then after that, I pick 4 because 2 squared is what would show up after that. Okay. I'm not going to make us graph this one right now. I want to do one more that's not going to work out quite as nice. All right. Last one. And then we have a couple more comments to make, but pretty much done there. Ooh, we could switch this a little. We'll be all right. Here we go. On delta, g of x is, let's say, 2x squared. We're going to make it negative 2x squared just for fun. Plus 3x plus 2. I'm going to give us a head start. I want you to quietly chat with your neighbors, or loudly, I don't care really, you guys aren't going to get too crazy. Chat with your neighbors, start working this out. I imagine everybody is going to begin by factoring out something. I'm going to give you a head start. But as we look at this problem, I know that if I were to take this number, 3/2, and I'm not even caring about the negative because I'm going to square it anyway. If I take 3/2, instead of dividing by 2, is there an easier way to think about it? Dividing by 2 is like multiplying by what? 1/2. Dividing by 2 is the same as multiplying by 1/2. Then I'm going to square it. So as I look at this, what's 3/2 times 1/2? So this is 3/4, and square it. 9/16. I'll add it, but I'll also do what? Subtract it. This is the hardest part of the whole problem. But as long as we all recognize that dividing by 2 is just the same as multiplying by 1/2, nothing weird has to happen. Okay, on my next line, what do I get rid of inside the parentheses? The negative, right? So let's do it. So I have negative 2, and then I really would probably just leave this alone here, or I would factor it as I'm going, but I'm okay if we don't. And let's think, when I distribute this through, how do you guys do it? Negative 2 times negative 9/16. If I just jump to call that 9/8, do you see where that happened? some of you do, some of you don't. I'm gonna take, you don't have to erase yours, I'm just taking a step back here. Negative 2 times negative 9/16 is that distribution I have to do. You could call this 18/16. Like that'd be fine. However, I notice a 2 goes into this once, and a 2 goes into that 8 times. There's my 9/8. Like I would simplify before I deal with it. So let's just see, that's negative 2. We still have x squared minus 3/2 x plus 9/16. Then out here we get a plus 9/8. And then plus, and before I write a 2, somebody suggest possibly a better way to write 2? I'm going to write it at 16/8. Why? Common denominator, so I can add them. Okay, this thing looks awful. Don't stress, it's not. We've done this to make it perfect. It doesn't look like it's going to be easy, but I assure you it is. Let's just try this out. Can somebody tell me the square root of the first term here, this x squared? X, good. Okay, what's the sign on the middle term? So minus. This one feels like it's going to be hard, but this is the reason why I told you not to change to decimals. The square root of 9/16 sounds gross. It's not. What's the square root of 9? And the square root of 16? 4 squared plus, it looks like 25/8. Can you tell me where the vertex is? So I think I heard Mickey say positive 3/4. And the y value? 25/8. Now, if you were making a table for this one, it's going to be ugly for a minute. Because you can't take a whole step of 1 away from 3/4, I'm sorry, to be at a nice value. Okay. Completing the square to get this thing into this form. Thumbs up, thumbs down. Okay. So, there's one little tweak that I would like to change about this. And I need a new screen, which I usually don't because this section has a bunch of examples. I don't have anywhere to write it. Cool. All right, we're going to do one more example. We're going to do it in biology class. Cool. Last example, I'm going to throw a curveball at it, see if we can make sense of it. Now, every single problem that we've just done, our entire effort was to say, find the equation in standard form, right, of this parabola, and I give you a full function. We're going to twist that just a skosh. For this problem, and I don't know why I would start there, that seems like an odd choice. For this problem, our example, I want to find a parabola that contains, we're going to give ourselves a couple points here. I want us to find a parabola that contains negative 6, 15 as an ordered pair with vertex at, I don't know, let's make it nice, negative 4, 11. Okay. Immediate links to the world of physics that we don't need to go into right this second, but it is certainly there. Man, that seems super duper hard. The good news is that we know the vertex. Somebody remind me real quick, what's the standard form or the vertex form of a parabola or a quadratic? I don't know the last number I called, but I'm going to say number 9. What is standard form for a quadratic? Or vertex form, or graphing form, whichever one we wrote down for today. Perfect. Now, this is the form, if you know the vertex, this is the form that's easiest to work with. What am I going to plug in for h and k here, number 10? Okay, so this is where we have to be really careful. I now know that this function, f of x, is equal to some number a, x minus negative 4. Right? Because that's the x coordinate, my h. What happens when I minus a negative? It adds. And then plus k comes out here. Have I done anything super duper crazy yet? To get the actual equation here, I literally only need to find a. X is itself, like I just need that number a. Now, it seems that you can't just magically pick it. But I know that this ordered pair up here is on my graph. If I ask what this looks like, and I word it a little bit better, somebody's inevitably going to think this. And you guys are right, that's xy, right? But I don't have a function called y, I have a function called f. If we just think of it instead as x comma f of x, does it still say the same thing? And there's a reason that I would do this. I know that when I plug in a negative 6 for x, what y value or what f of x does it spit out? According to this, if I plug in a negative 6, it spits out 15. Let's use this point. Let's plug this point right into here. I know that the y value or the f of x value is 15, and that happens when I plug in a what for x? A negative 6. I think that we can solve this for a. In fact, I think you can solve this for a. Do so, meow. If you are getting it goofed up on the negative sign, like it's easy to do, if you natural reaction is to grab your calculator, I don't hate it as long as you're careful. I don't think you guys actually need it though. If I take little steps, that's first step, right? Now I don't need my calculator for this, I don't think. What's negative 2 times negative 2? If you made a mistake, this is where it's going to happen. Now instead of calling it A4, I'm going to rewrite it as 4A because it's more natural. Plus 11. I'll subtract 11 from each side. And I get A is equal to 1. We're not done. Not quite. We're pretty much done. But what are we actually supposed to do? What were we asked? We're supposed to find the parabola. We just found A. It'd be a shame if we didn't get it because we just didn't take this last little step. This function is f of x equals 1. I'm not even going to write it. You can if you want to. X plus 4 squared plus 11. We done. Easy peasy. Okay. I'm going to write one last statement, and then you guys are going to have about 15 minutes to work on your stuff. This last one. This stuff gets easier with practice, and this is unbelievably valuable. Turns out completing the square gets used in a lot of random places that if any of you pursue engineering or math or something, I remember being like a junior in college and somebody did it and I was like, what the hell did you just do? And I couldn't tell what they did because I didn't remember it because I'd only seen it for like just a minute in my Algebra 2 class. Okay, as we're looking at this, we're going to make one last little statement. We just spent a ton of time and a ton of examples finding the vertex form, to find the vertex. Now, turns out there's another way to get this, and I'm just going to make a statement, and 9 times out of 10, I would rather just take the 30 extra seconds to complete the square to do this, because this one gets ugly and people get goofed up. If I instead give us this, ax squared plus bx plus c, which we have, and then we change it to vertex form. If you are just dead set on graphing this and you decide you hate vertex form and it's stupid, you're not going to do it, that's okay, because there's another way you can graph this easily by finding the vertex without doing all that. If this is our function, then the vertex is at, and I'm going to center this, and I have to write big because we get some fractions coming in. I guarantee, no matter what this function is, ax squared plus bx plus c, as long as a is not 0, the vertex of this that we can find by doing this, completing the square thing, or you can just do this. Negative b over 2a is the x value that you will always get. And then if this is the x value that I have, I just have to plug it back into my function, right? So like if this were a 4 for x, I know that the vertex happens at 4 and whatever I get when I plug in 4 into the function. This looks really ugly, but it's f of negative b over 2a. You can always find the vertex this way. It is not super nice because oftentimes you get really ugly numbers. But if all you need to identify is the vertex and you don't have to graph it and do all those things, maybe this is a more efficient route through the problem. Does that look familiar at all? Some of you maybe, some of you not. That's okay. All right. So right now you get the opportunity to knock some stuff out. So here we go. We're 4th hour. Please say I saved it. I did. It's super odd format, but I did save it. Okay, you guys get the next 15 or so minutes. Quit it. Quit it. Cool. You get homework 2.1. What? Okay. Homework 2.1, page 120. You get problems 1 through 8, and I have the sneaking suspicion. Did I tell you guys I was going to quit doing vocab?
Yeah.
I lied to you. Yeah, you'll be all right. 1 through 8, 19, 23, 27, 29, 31, 47, 53. And let me see if there's any. If you ever see one that says graph, like 19, 23, 27, 29, rough sketch is fine. Rough sketch with at least, yeah, rough sketch is fine. You don't have to go like super crazy about it. Now, there's one little piece of language we haven't used, the axis of symmetry. Every parabola has a vertical line that runs through its vertex. That is your axis of symmetry. It's just a line that you reflect over. I didn't refer to it as such, but we've used it over and over and over. The x-coordinate of your vertex is known as your axis of symmetry for your parabola. Cool, 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 cool. All right, I'm going to publish a video and answer some questions if needed.